Alright, here is the video for task number 2. Again, if you have not put these two triangles in your notes, go ahead and make sure you put those down as well. You also might want to pause the video if you don't remember that sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Some might have memorized this as SOHCAHTOA. So we're going to use SOHCAHTOA today and our special right triangles to find the exact values for each ratio. So remember, ratio is comparing one thing to another. And so if we're looking at sine of 45 degrees, we're comparing the opposite over the hypotenuse. And if I go look at my special right triangle that's 45, 45, 90, I can pick either this 45 degree angle or that 45 degree angle. So let's say we pick this one. What's my side that's opposite? Well, it's S. And then what's my hypotenuse? It's S root 2. Now, that looks pretty good. We could simplify and get 1 over root 2. And notice how all my variables just kind of cancel out. But this isn't proper form, so we're going to want to multiply top and bottom by root 2 over root 2. Giving me sine of 45 degrees is really root 2 over 2. All right, and this is a really important number to remember because you're only going to see root 2 over 2 associated with the 45, 45, 90 triangle, both here when I'm just looking at triangles and on the unit circle. All right, let's go look at cosine of 30. We know that cosine of 30 degrees, what we're looking for instead of opposite this time, is adjacent over hypotenuse. And we must be looking at our 30, 60, 90 triangle. So let me zoom out. And we can see what is adjacent to 30 degrees is this S root 3. Adjacent, that word means next to. So if I'm looking at 30 degrees, I'm not looking at the side opposite. I'm looking at the side next to it. So this one is going to be S root 3. That's my adjacent. Now if I go back and look up here, I can see my hypotenuse is 2S. All right, so over 2S. This can be simplified. S divided by S is just 1. So cosine of 30 degrees is root 3 over 2. And it's always root 3 over 2. And root 3 over 2 is always associated with the 30, 60, 90 special right triangle, both now and when we look at them on the unit circle. All right. Last but not least, tangent of 60 degrees. So tangent, SOHCAHTOA, it's going to be opposite over adjacent. And then let's bring that opposite over adjacent into our view here. So here's 60 degrees. My side opposite of it is S root 3. All right. My side adjacent to 60 degrees, or next to, is just S. So we can see that when these S's cancel out, tangent of 60 degrees is just root 3. All right. Keep all of those in mind. Take a moment if you need to, pause and fill in any notes you might have missed. We're going to use that for an exercise. You guys are going to want to have your special right triangle available so that you can do these. You're going to want to pause your video, and work on these, and then I'll come back and we'll go over them together. All right, I'm hoping that you guys took the time to find these using the ratios we just talked about. So for 45 degrees, that's my 45, 45, 90 triangle. I know that I have something like this. And so if I'm asking, and these are 45, this is 45, and this is 90. So it doesn't matter which 45-degree angle I take. I'm just going to pick this one. Cosine of 45 degrees. So cosine is adjacent. It really doesn't matter in this case because whether you're adjacent or opposite, it's s. And then your hypotenuse is s root 2. So again, those cancel out, giving me 1 over root 2. If I rationalize that, root 2 over root 2 gives me root 2 over just 2. So cosine of 45 degrees happens to be the same as sine of 45 degrees just because both sides of a 45, 45, 90 triangle are equal. All right, so let's try sine of 30. So our 30, 60, 90 triangle, here's 30, here's 60, here's 90. Remember, our short side is s, our hypotenuse is 2 times that short side, and my long side is s root 3. So I'm here at 30 degrees. The side opposite of 30 degrees is s. So sine of 30 is going to equal s. All over my hypotenuse is 2s. These are going to cancel out. So I get just 1/2. Again, 1/2 is always associated with sine 30 or of the short side of your 30, 60, 90 triangle. All right, last but not least, we have tangent 30. We're still going to use this little drawing we did down here to do tangent of 30. Tangent of 30 is opposite over adjacent. So here's my opposite, which is s. Here's my adjacent, s root 3. We know those s's cancel out, giving me 1 over root 3. Now I want to rationalize that, so multiply by root 3 all over root 3. And tangent of 30 gives me just root 3 on top and just 3 on the bottom. All right. So let's sum up all the values that we got from the last 2 slides. So associated with 45, 45, 90, we pretty much only had a couple of different values. One was root 2 over 2. That was associated with sine or cosine. And one we didn't do was tangent. But if we looked at tangent, it'd be side over side. So we would get just 1. So that's tangent. And if we came over here to our 30, 60, 90 triangle, we had a couple of different values. One was 1/2, and that's really sine of 30, or if you think about it, cosine of 60. We had tangent of 30 gave me root 3 over 3, so that's tangent of 30. Tangent of 60 gave me just root 3. And what we got on our previous page was we had the cosine of 30 was root 3 over 2. Coincidentally, that would be the same as sine of 60. So here's really the only values that are associated with these two special right triangles. So maybe put those in your notes. That'll be helpful down the line. Right. Last but not least is then we want to use that knowledge that we just wrote down, and we want to decide what angle am I finding on this? All right, so if we come up here with cosine of x, we're solving for x this time. And so cosine of what angle would give me root 2 over 2? So we come back, we look at our notes. Well, it really doesn't matter, but I know it's associated with the 45, 45, 90 triangle. And so either sine or cosine gave me that root 2 over 2. So I'm going to say in this case, x is 45 degrees. All right, and if you guys want to go through this little exercise by yourself before I give the answers, go ahead and pause right now and see if you can come up with the same information. All right, if you took a look back at your notes, tan of x is opposite over adjacent, so both of those sides have to be equal. So we also know in this case it must be 45 degrees. And then now if I look at these last two, the only time I got root 3 over 2 for any of my triangles was 30, 60, 90. So I just got to get it right. So I just found on that first page that we did that cosine of 30 degrees was root 3 over 2. So I'm going to say this is 30 degrees. How would I know for sure? I could make myself a note. This is 30, this is 60, this is 90. I know my short side is s, my hypotenuse is 2s, and my long side is s root 3. So what would give me root 3 over 2? Well, it'd be adjacent over opposite of this 30 degrees. So it has to be 30 degrees. Now we're talking sine of x. It's root 3 over 2, but this is opposite over hypotenuse. So what opposite over hypotenuse would give you a root 3 on top and a 2 on the bottom? Well, we can see that it would be s root 3 divided by 2s. And so that's opposite the 60 degrees. So in this case, x equals 60 degrees. Right. Hopefully you guys remembered some of that from geometry and from Algebra 2, and this won't be too confusing, but again, I'm always available for notes or one-on-one Zooms or having office hours with several of you. So I hope this was a helpful video, and I'm out till next week.